Okay, 8.4, dealing with the polar coordinates. We covered graphing them, which we talked about how you have to rotate first. So you think of it as turning the spinner. Then you walk out if it's positive R towards the spinner, or you walk back if it's negative R in the opposite direction. Then we looked at converting back and forth between polar and rectangular coordinates. Rectangular coordinates would be traditional X, Y coordinates. Polar coordinates are in the form R theta. Then we worked on converting in reverse from polar coordinates to rectangular coordinates. And then now what we're going to look at is the exact same concept, except instead of it being the coordinates, it's the equations. Which is probably the most uncomfortable part, because once you see what it looks like when it's done, it just feels like you're just not done. So it's kind of awkward. But it's very simple and straightforward, and it's just a matter of following the formulas that will be given to you. So if you look right here, first of all, you know it's a rectangular coordinate if you see the X and the Y. When we get to, I think it's the next slide. Yeah, when we get to the next slide, if you kind of preview ahead, you'll see that the equations in the next slide have an R. So that lets you know that they're in polar form. So coming to this one right here, the goal is to go to polar form. And what we mean by that is where we have X, we want it in terms of R cosine theta. Where we have Y, we want it in terms of R sine theta. And that's how you start the problem. So right here, X squared plus Y squared equals 25. If I'm going to polar form, X is R cosine theta. Y is R sine theta. Notice everything else I've left alone. So it's already in polar form right there, but they do want you to clean it up. And ideally, not every time, you get R by itself if it's pretty in doing that. And I'll show you an example of where it's not pretty in doing that, and you can see where you just leave it alone. So here we need to clean this up. Be careful when you are taking R cosine theta and squaring it. You're squaring the R and you're squaring the cosine theta. So this becomes R squared cosine squared theta. Put it in the correct spot. Don't put it after the theta. That would change the angle, which is, that's not like you don't change the angle. Here we would have R squared sine squared theta equals 25. What do they both have? What do you notice? They both have an R squared. So let's factor an R squared to the front. R squared, I'm going to pull that common factor to the front, which would leave me with cosine squared plus sine squared. This should be fun. Do you remember what cosine squared plus sine squared is? It's 1. So when I write right underneath this R squared times 1, hopefully you remember where that 1 comes from. Now that's not saying that all of a sudden all those trig identities are coming back, not at all. It's just saying that R squared plus sine squared is 1, and so here we want to simplify that. So right here we can write R squared is 25, and we want to get it in the form of just R. How would I undo the square? square root, right? Square root of both sides. So R is 5. We're not writing positive or negative 5 here because we're not solving like a quadratic equation or anything. We're converting to polar form. So if R squared is 25, that comes from R being 5. So I want you to make a note on your paper, and on mine I wrote it underneath, but so this is the polar equation of this rectangular equation, and I want you to make a note. We'll draw an arrow to show that those are the same thing. So here, the polar, and I'm going to abbreviate equation, maybe, if I can remember how to spell it. Equate EQ. I'm going to abbreviate equation with EQ. Here, the polar equation is cleaner. So this is what I was talking about with this particular type of question is awkward because like when you look at that, you don't think of that as an actual equation. You probably think of that as just being told, hey, R is 5. But that is the polar equation that would represent this rectangular equation. They're one and the same. Let's repeat. Come over here. I want you to start it. You start it the same way. You're going to replace, and if you need to make notes to yourself that it's a matter of replace x with r cosine theta and y with r sine theta. Not a lot to clean up here once you plug it in. 2 times r cosine theta can just be written as 2r cosine theta. This negative right here just naturally makes this positive become a negative, so basically you're dropping the parentheses. Now again, what do they have in common here? They have an r in common. Let's pull an r to the front, which would leave me, if I factor that to the front, I'd be left with this. And this is where it's awkward because this is where you could stop. You might think, oh, I need to divide that underneath the 5 because then r would be by itself. You can, it's the same thing. But in this particular case, let me draw the arrow. Here, the rectangular equation is cleaner. So sometimes the polar equation is cleaner, and by cleaner we just mean, I guess, more simple, less mess. But here the rectangular equation is cleaner as opposed to the polar equation. Now what we're going to do is the exact same approach but in reverse. We're going to go in reverse from a polar equation to a rectangular equation, which is, in my personal opinion, less messy. There's not as many steps involved. So if you come to this slide right here, it's saying go to rectangular form, which lets you know your goal should have an x and a y or one of the two, right? So look at A. This will help you understand how that answer in the last one where we said R is 5, this will help you understand how that represents a whole polar equation. All right. On A, we have R is 4. Okay, so we're going to polar, which means I need to use R in terms of X and Y. I'm not going to polar, we're going to rectangular. I need X and Y in here. Well, what is R? What's R? Square root of the X squared plus Y squared. So let's substitute that in so that we now no longer have an R, now we have an X and Y in there. So right here, I'm gonna draw an arrow to kind of say, remember, like R is the square root of X squared plus Y squared. So I'm going to replace R with the square root of X squared plus Y squared. Bring down the equals 4. Now the R is gone. So the very first step in both of these slides, no matter which form you're going to or from, the first step is to replace the form you're in with the formula for the form you need. Okay? So if you're in XY, we've got to replace them with R sine and R cosine. If you're in R, we've got to replace it with the square root of X squared plus Y squared, because the goal is to get it to the other format. Then from there on out, it's just clean it up. So right here, this is really ugly. I can get rid of this giant square root by doing what to both sides? Squaring. I can just square both sides. And that's going to cancel that root on the left. And then on the right, of course, I get 16. And in this case, hopefully now you can see where that last slide that we had, I'm going to go back to it. It started out like this, and then it ended at R is 5. Now you can see the connection between the two. Here, R is 4. Well, in rectangular form, it would be X squared plus Y squared equals 16. And let's connect the dots even more. Remember Pythagorean theorem? Right? A squared plus B squared equals C squared. I have the light right in my eyes, so I have no clue you're looking at me. If R is 4, that would be the radius, which is what part of the Pythagorean theorem? The C squared. So that goes right there, and then this is the rest of the triangle. So that's the connection between the polar, the rectangular, and the Pythagorean theorem. You do have to be careful here. And what we mean by be careful here is because we are taking this entire equation and we're squaring it, right? We are possibly introducing extraneous solutions where if you were to take this and like solve it, because we took the equation and we squared it, we've just opened up the can of worms that we could have just allowed extraneous solutions to fall in the answer box, which we're not solving them right now. But you just have to be careful. If you ever square to get rid of a square root, is when you're opening up that can of worms of extra answers coming in that are actually not supposed to be there. And it's because you squared it. Does that make sense? That's the whole concept behind, like, what is the square root of the number? Well, I don't know. It could have been the positive or the negative. Well, the same concept applies when you're going in the opposite direction. If I'm trying to get rid of the square root by squaring, I'm now allowing that possibility of extra answers coming in that are actually not applicable. So make a note, be careful. What? Oh, that's, yep. Watch out for introducing I'll just say extraneous solutions. And that all comes from squaring. right, let's look at the next one. We have r cosine theta equals 6. We want to go to rectangular form. So when you're first looking at it, if your first thought is replace r with the square root of x squared plus y squared, that's probably going to get really ugly with that cosine. That's not going to help the cosine, right? So this is where you have to look at your formula sheet and ask yourself, what would be helpful here? Well, what do you notice? It's the exact same thing right there. So x is r cosine theta, which happens to be exactly what I see right there. So this one is so simple, you feel like you're wrong. Now you might be thinking, how is that at all the rectangular form of any polar form? Well, this is a vertical line. So that's how that's still, applicable. That's, remember, avoid bucks, vertical lines, undefined slope, and they're in the form x equals a number. So that's a vertical line. Okay, the next part is very short and sweet, and it involves your calculator. Let me pull mine up. We are looking at what polar equations look like in the calculator. So if you look at this one right here, first of all, you do have to make sure your calculator is in polar mode. And then when we're finished with this, if you don't mind to put it back to regular mode because it'll throw my sophomores off. Go to mode. Your calculator is by default in function mode. We're going to arrow down and over to polar mode, hit enter. Then just clear out. Alright, I'm going to go to this right here. So the example we have is, it says graph. Now first of all, when you go to these homework assignments, please pay attention to the directions. If it says graph, then clearly get your calculator and let the calculator do the work. Just make sure you're in the correct mode. It says graph r equals 1 minus sine theta. You need to make sure that the equation has r by itself before you can go to, we call it y equals. So I'm going to make a note. Like y has to be by itself to graph, and I'm talking about in the calculator, r must be by itself. In this example, r is already by itself. So we're going to go to our, we still call it y equals though. We're going to go to y equals. We're going to enter the right side of the equation, and then we're going to just look at the table, and then we're going to look at the graph. So r here is kind of like your y equals to keep a parallelism between them. Okay, so y equals, you'll notice it already has the r's. Ours is 1 minus sine theta. Theta is the button you've been using as x. My fingers in Oh, I missed it. There it is. Zoom trig. Well, mine's not coming out through. Y'all's? It's Zoom 6. Zoom 6. Yeah. Did you type? Did you make sure you're in color mode? Oh, you have a plot on. Hit that. Turn it off. Now Zoom 6. Oh Lord. You know, the kids do it. Ignore the picture. I don't know how they do it. She has like a drink. What is it? A sink.
Yeah, I had a sink on mine too.
Yeah. Anyways, that's great. All right, R has to be by itself, and then once you enter it in R equals, then you're gonna hit Zoom 6. Now I'm gonna zoom in just so I can get a better idea of what I'm looking at. There you go. It's like a peach. So on your paper right here, if you want, you can just sketch. Oh, not bad. Like a little kidney bean. I was trying to stay away from that. I was skirting around everything but that one. Okay, go to this one. Did I already put this one on there for you? No? Oh. Is that what yours says? Yeah, okay. We are graphing R equals 4 sine 3 theta. 4 sine 3 theta. And we've been given specific windows to use. Doesn't matter which window you use as long as you pick one. Alright, so go to your calculator. Let's go to R equals. What are we graphing? 4 sine 3 theta. Then we're going to go to window. I'm just going to do, I'll do degrees first. It should come out to the same. So my min is 0, my max is 360, and my step, meaning intervals between, is 1. Then when you're adjusting the window, you have to hit the graph button for it to take that into consideration. Now, I can clearly see it. I might want to zoom out a little bit because I'm cutting off part of it. So there is a zoom out button. You just hit zoom, then out is the third option, and you're going to see a flashing cursor. That means where do you want us to center where we're zooming out. So I just leave it right there. Oh, I'll stop it. There you go. So just briefly sketch that on your paper. You can make a note to yourself, you know, that this was an adjustment of the window. I personally like polar graphs. I don't like dealing with them because they're just awkward, but I do like graphs in general because I think they're neat. The purpose of the next slide is just to show you that sometimes R is not by itself, which means you can't run to the calculator until you get it by itself. And then you can graph it just like normal. So
whenever you're doing this, and it gives you the R and have to graph it, how do we do that on like my math lab?
I think they give you the graph pictures, it's multiple choice. Yeah. So look at this one. The point of this one is to remind you that R has to be by itself. And it's not. And the only thing in the way is the positive 1. So I'm going to subtract the positive 1 to the right. Don't overthink this. I just put it at the very end. So you have 2 cosine of 2 theta and then minus 1. Then go to your calculator, type that in, R equals 2 cosine 2 theta. You do need to close the parentheses there before you type minus 1. And then because we adjusted the window in the last one to 0 to 360, we could see if that's convenient here by just hitting the graph button. And you can see it. I probably would zoom in a little just to see a little more. I zoomed in a little too much. Now I've cut off the top and bottom. But anyways, you get the idea. There's the picture. So this section entailed 3 things. Going from polar to rectangular coordinates. Going from polar, actually 4 things, graphing. Forgot about graphing. Graphing them. Going from polar to rectangular coordinates and vice versa.